Welcome to HKS CAD. This will be the first video on this channel. Today, we're diving into the fascinating world of process piping components. Whether you're a seasoned engineer, a student, or just curious about how industries transport fluids, this video is for you. We'll break down everything from pipes and fittings to valves and flanges, explaining their functions and how they come together to create efficient and safe systems. Stay tuned, hit that like button, and subscribe for more insightful content on engineering and technology. Let's get started.
Stay tuned, hit that like button, and subscribe for more insightful content on engineering and technology. Let's get started. First, let's see what is piping. Piping systems include pipes, fittings, pumps, valves, and tanks. Process piping systems can be quite complex as they are interconnected and often include additional components like separators, flanges, pressure hoses, traps, strainers, and gaskets. These components play a crucial role in separating and controlling the flow of substances. A facility's fluids, gases, and other materials are moved about via a system of pipes, valves, and other parts known as process piping. It is utilized in numerous industries, including the following, and is an essential component of many industrial and manufacturing processes: oil refineries, chemical processing plants, food and beverage facilities, power plants, paper mills, brewers, wastewater treatment facilities, pharmaceuticals, HVAC systems. Now, we will learn about the foundation of engineering, which are codes and standards, because they offer the norms, rules, and best practices necessary to guarantee the dependability, safety, and quality of goods and services. They can also assist in lowering the likelihood of mishaps and injuries. Various fields use codes, standards, and specifications to guarantee performance, safety, quality, and consistency. They are employed in various circumstances and for multiple goals. ASME established guidelines and standards pertaining to the pressure vessel sector in response to the spike in injuries that occurred during the Industrial Revolution. As an international association, ASME is well known today, particularly in the oil and gas sector. Numerous well-recognized ASME standards and rules guarantee that manufacturing machinery reaches its maximum potential without endangering people or the environment. Now, let's see what are codes. Codes are a set of widely recognized guidelines that specify what must be done. A standard becomes a code when it is incorporated into a business contract or is approved by one or more governmental entities and becomes legally enforceable. Codes are rules or regulations that provide minimum requirements to protect health and safety in the field of mechanical engineering. They are frequently taken from formally published papers known as standards and converted into legislation, government regulations, or legally binding contracts. Codes, standards, and specifications are used in a variety of fields to ensure uniformity, quality, safety, and performance. They are used for a variety of purposes and in a variety of situations. For instance, considering that ASME's mission is to advance engineering for the good of humanity. In reaction to the increase in injuries that transpired during the Industrial Revolution, ASME set guidelines and standards regarding the pressure vessel industry. Today, ASME is a well-known multinational association, especially in the oil and gas industry. Several widely accepted ASME standards and guidelines ensure that manufacturing machinery operates to its fullest capacity without posing a risk to individuals or the environment. The American Society of Mechanical Engineers, ASME, develops rules to ensure safety, quality, and regulatory compliance in the operation of pressure vessels and industrial equipment. Now, let's see what are the standards. Specific standards and guidelines for practices, procedures, and methods. Standards are typically more detailed than codes and are frequently the result of an agreement on best practices. Standards provide technical definitions and guidelines that provide guidance to equipment makers, users, operators, and designers. They provide quality, safety, and uniformity for goods, processes, techniques, or activities by defining consistent technical requirements. In engineering and related technical domains, standards are crucial technical publications. Technical standards are accepted guidelines or specifications. A formal document that sets standard engineering or technical criteria, procedures, techniques, and practices. The official committee or group's documents that are deemed to be appropriate and proper engineering procedures and that include required specifications. Around the world, thousands of standards are in use. From the most basic screw thread to the most intricate information technology network, they cover it all. By implementing standards, organizations can contribute to ensuring that their goods and services are reliable, safe, and efficient. Standards are more crucial than ever because products are now constructed from parts sourced from multiple nations and sold worldwide. In addition, the phrase code and standards is widely used in many industries, especially in the equipment construction industry. This is because the code may set a lower threshold even when the standard provides a thorough method to satisfy or assess the minimal safety or performance. The technical specifications of any particular process or product should be described precisely and in detail. Often, private businesses create specifications to handle extra needs relevant to a particular product or use. Engineers, managers, and buyers employ these contractual contracts, which set the guidelines for the procedure. In engineering, specifications are detailed documents that outline the requirements and features for a product, design, or service to meet. They can also refer to a set of documented requirements that material or workmanship must meet to complete an engineering project. Specifications are often a type of technical standard and are usually prepared by architects, engineers, and specifiers. Let's take one example, to complement the minimal criteria of the relevant codes. This specification addresses the general requirements for the design, manufacturing, erection, inspection, testing, and supply of unfired pressure vessels. Pressure vessel specifications may include the following. Pressure. Minor pieces do not limit the highest possible working pressure, the shell or head does. Terms and values like service pressure and design pressure can be used to describe pressures. Materials. Carbon steel, carbon manganese steel, and low alloy steels are just a few of the materials that can be used to create pressure vessels. Design. A pressure vessel's design should take the type of fluid or gas being kept, its temperature, and the material's characteristics into account. The most popular design is a two-headed cylinder. Painting. High solids epoxy coating in 2 components should be applied to insulated vessels. 2 coats should be applied to uninsulated vessels. Delivery. In addition to having a gauge valve, and safety stickers showing that the vessel is being shipped under pressure, vessels should be shipped with dry nitrogen. Since we saw that specification addresses general requirements, we must need it to fulfill the development of the product. A specification is essential to the development of a product. A specification is an in-depth explanation of the layout and components utilized in the creation of an object. It is the act of accurately identifying something or clearly and completely conveying a demand. 3 fundamental sorts of specifications are possible. A requirement specification is a list of formal specifications that a material, design, product, or service must meet. A functional specification, which may include functional block diagrams, is a requirement outlining the functionalities that the product must fulfill. A design or product specification outlines the particular characteristics incorporated into the product's design. It offers details about a product's features to verify whether the creators have adhered to the requirements. Like ASME, BPVC code provides specification for materials in Section 2 Part A and Part B. Section 2 Part C provides specifications for welding rods, electrodes, and filler metals. We'll study about process piping components in the upcoming video. Until we learn and advance, see you.